Hello students, myself Utpal Madhu, Assistant Professor of Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. Today I shall discuss about zero-dimensional defect or point defects. Now defects can be classified as zero-dimensional, one-dimensional, two-dimensional and three-dimensional defects. For zero-dimensional defect there are many types of defects like vacancy, interstitial, impurity, Frenkel, Schottky, etc. Now zero-dimensional defects are also called point defects. Point defects are accounted for when the crystallization process occurs at a very fast rate. These defects mainly happen due to deviation in the arrangement of constituting particles. In a crystalline solid, when the ideal arrangement of solid is distorted around a point or atom, it is called a point defect. Vacancy, interstitial, substitutional, Frenkel, Schottky, impurity, these are point defects. Now, in this figure, there is vacancy, interstitial, substitutional, self-interstitial, and Frenkel pair and Schottky defects. Now, when a matrix atom shifted from its regular position, then vacancy created. When a foreign atom, that is a larger atom, replaces a matrix atom, then it is called a substitutional impurity. When a smaller atom takes place in interstitial position, then it is called interstitial impurity. When a regular matrix atom takes place in interstitial position, then two types of defects occurs. One is vacancy and another is self-interstitial. This combination is called Frenkel defect. So, in zero-dimensional defect, there may be vacancy, interstitial, self-interstitial, substitutional, Frenkel and Schottky, this type of defects. In Schottky defects, when anion vacancy associated with cation vacancy, then two defects occur and it makes electrical neutrality. And in case of Frenkel defect, one vacancy and one self-interstitial. This pair of defects is called Frenkel defect. For example, in silver chloride, a silver ion can move into an interstitial site. And in case of Schottky defect, in sodium chloride, missing sodium plus and chlorine minus pair, these two defects is called Schottky defect. Now, effect of zero-dimensional defects on material properties. In case of mechanical properties, increased strength by hindering dislocation motion can cause brittleness at high defect concentration, accelerate creep at high temperatures. In case of electrical properties, doping, which is substitutional atoms, modifies conductivity. Vacancies and impurities scatter charge carriers, reducing mobility. Thermal properties reduce thermal conductivity by scattering photon. Diffusion, vacancies and interstitial enhance atomic diffusion rates. And chemical properties, defect act as active sites, increasing chemical reactivity, which is important for catalysis. Thank you for patience hearing.